find it.
Okay, we are going to talk really quickly about the equalizing circuit. I'm not going to go over how this all works because you'll just be very angry with me for doing so and go, is that on the test? The point that I need to make here is, and we've already made this, when you have multiple generators, in other words, you have a multi-engine aircraft, the generators have to be paralleled, which means they both have to have nearly an identical output. So you have to get them very, very close by adjusting the voltages on each one with the screw that we talked about. And if you open up the manual for a twin engine aircraft, it will explain how to get them very close and what you're allowed to do. And then from there, once they're very, very close, you have an equalizing circuit, which is actually what this is, that will then match them by going through voltage coils and equalizing circuits. And I do have all the notes to do this if you really want to, but you really don't. And how it works with the sensing, equalizing shunt, why that resistor is there, and on and on. But it would just be a kind of a waste of time here. But anyway, that's what that is doing. That is equalizing them across this bus so that they're both sharing the load. Because if one of them was had a little bit higher voltage than the other, a couple of volts, 5 volts, then if you kind of think about what we learned about the reverse current cutout, now we've got a generator, which is acting like a battery, going through a reverse current cutout. This one over here has got more current than this one, so which way is it going to go through the reverse current cutout? Backwards and open those points up. So this one then carries 100% of the load. And the only way you're going to get this one to do anything is to shut this one off. So then you're going to be running right or left generators. You want them both on, sharing the load, so each one's doing half the work. So you get them very close, and then and then they run through an equalizer circuit that actually matches them by adjusting. So you have a little coil right here that's going to basically sense the voltage, and that will then move a little wiper across the regulating resistance. So if one of them this one's a little bit higher, Gen 1, then this will add a little bit more resistance to the field of Gen 1, drop the field down a little bit so that it matches Gen 2. And that's all we need to know about that. All right. Let me see, reverse current cutout, and then I was going to talk about the equalizing circuit. Let's see, didn't we already kind of cover this? I'm hearing crickets.
Yeah, we covered this.
Must have generators paralleled. So the drawing I just showed you, it had coils and all that kind of stuff, but obviously a modern aircraft can have all solid state stuff. So, and I think we can let that go right there. Troubleshooting. Oh, this is much more fun. Troubleshooting. Oh, I've had a lot of fun troubleshooting generators in my days. If a generator doesn't work, what's the easiest way to fix it?
Replace it. Get a new one.
Take the generator and the voltage regulator off and send it out for repair.
Parts cannon. Always works.
A what?
Parts cannon.
Parts. Oh, just blast parts at it?
Yeah.
Okay, this is not a joke. The wonderful thing about working on twin engine aircraft is that there's always a bunch of spare parts on the other side. And you laugh, but that is troubleshooting 101. Hey, this generator is not working. I don't know, is it the generator or the voltage regulator? Let's swap voltage regulators and see what happens. That's what they do. They being me and everybody else. If you can't troubleshoot it, then you just take it off, swap them, and now they both don't work. So what does that tell you?
The generator itself is failing.
Yeah, you got a problem with the wiring going to one of the voltage regulators, just blew up 2 of them.
A generator and a B generator.
Yes. So we got to be careful of that. All right, let's see. No or low voltage? No or low voltage? Come on, so you've learned all about generators. What are you thinking?
It's got an open or a close where it shouldn't.
Nice.
Is he wrong though?
No or low voltage where? In the battery? At the battery?
Output voltage of the generator.
No or low voltage.
Maybe I should not do no or low. We should do one or the other. Ask some other things. What are some other troubleshooting? You know,
It could be.
what do most aircraft have? Now my aircraft has both voltmeter and an ammeter. So it's really common for aircraft to have ammeters, not like cars. We want to know what's going on. And so, what does the ammeter tell us again in small aircraft?
Tells you how many amps it's coming out.
How many amps are going into the battery, out of the battery? Larger aircraft will usually tell you what the generator output is, so they're a little different. So our simulator troubleshooting, what the hell's it called? The EST, yes, and you guys had a nice acronym for it. That particular ammeter shows us the generator load, like it's a large aircraft. So, all right, so let's say, okay, ammeter. Let's talk about the ammeter then.
Well, no or low voltage. It could just be off.
Ammeter. Could be off. So what do you do?
Turn it on.
Turn it on the aircraft.
You'd be surprised. I built this aircraft and completely restored it, and I hadn't seen it for decades. And then I ended up working at a place, and it shows up, and I'm like, "Whoa, check it out! I haven't seen it for decades." And the guy's body's all proud, and I go in there, he's got wires all over the place. I'm like, why do you have like this? It's in my intercom. It's a portable intercom system, so we can talk. I'm like, dude, there's an installed intercom right there. You're like, whoa, nobody told me that. People don't know. So ammeter. Let's see. What if it has a discharge? Seek a doctor. What if it's showing a discharge? What does that tell you about the output of the?
It's stuck open.
Do we have any sort of output of the alternator?
No, it's not charging your battery.
Nope. So we're not charging a battery. We're just seeing a discharge. So where would you check it?
The voltage.
The reverse current limiter.
So think about it. Now, of course, we have a propeller spinning up. Be careful, but that's what little jumper wires are for. Like if I want to check output of a generator, I don't want to sit there with my voltmeter while the engine's running. So I'll just take a voltmeter inside the aircraft with me and use my little jumper wires and put wires going from the engine all the way into the cockpit, and I'll sit there and run it and look what's going on. So let me see. Maybe I shouldn't write this. So where would we check generator output?
At the post.
Ground and
At A and on the body of the generator itself.
I would check the output at the A plus post. What's that going to show me?
and ground.
Between A plus and ground, yeah. What's the A plus on the generator?
Output.
Arms positive.
That's the output to the aircraft. So I'm going to check that. Well, what if I get nothing?
Then you're not outputting anything.
Okay, so if I have no volts, what does that tell me about the generator?
That there might not be
That would
any
be-
field windings. If it's
it's-
well, the generator, I guess,
It's not
might
even
have residuals.
What should I see?
at least 2
At least
volts.
2 volts.
And I see nothing, so what's my problem?
The whole generator. Just-
It could be polarized, not polarized maybe.
All right, then I have no magnetism.
That could be a problem.
I've lost the magnetism of my pole shoes. So what do I do to fix that?
Field flash.
You pull it out and
Flash the field.
flash it up. Huh?
That's he flash it.
Oh, yeah, you gotta,
Flash field.
You gotta like.
We'll get into that.
Make sure everything's
Okay.
connected from
We have
the
to-
aircraft touch it over.
What?
I thought it was more of like a go team go.
So opening up my trench coat. No, so we have no residual magnetism in those fields. Well, we'll talk about that. What if we have 2 to 6 volts? Then what?
Your field isn't getting enough. Your fields aren't getting enough voltage. So
There we go. So now it's running on residual magnetism. So if it's running on residual magnetism, that right there, that's how you spell magnetism now, then we have a problem with the field windings. Well, maybe the field windings are bad. Maybe the voltage regulator is not sending anything back. So now we have all those things.
It'd be
So
helpful if we could like
Could-
see that, the drawing
Could
of
the
it.
commutator being dirty cause something like this, where it's
Could a
not
commu-
smooth?
being dirty and wore out.
Where you need like
No, if we're getting the voltage out, then the commutator's outputting it.
Okay, so there's okay.
So that's good enough, or clean enough.
Yeah.
Let's say for some reason the mechanic prior didn't do their job properly and the brushes are bad, would we get no volts as well?
If the brushes were bad,
Or if brushes?
yeah, it could be bad brushes. So
Point stain.
let me see. I got 2 to 6 volts. Well, it's a field circuit failure now. So which is what we figured. The generator's working because it's running off residual magnetism, but I have a field
So the points
circuit
could be stuck
failure.
open?
What?
The points could be stuck open.
Freaking idea. Faulty gen switch. Faulty generator switch. Little switch in the cockpit. Maybe that's a problem. We could have bad wire connections. Hey, I've seen how mechanics put stuff together. Do you have a wrench on you? No. Finger tight. It'll be fine. Bad voltage regulator.
Somebody flashed it wrong.
More than likely somebody flashed it wrong. Yes. You flash the field, then buy a new one. Or bad generator field. Bad.
So bad voltage regulator, could you also get over voltage because of that too?
Of course, yeah. All right, what if we have, let's see, no voltage?
No voltage. No magnetism.
No voltage.
Do we?
No,
I thought we already did that. Right?
Yeah,
No
no,
current.
Yeah, I know, but I just write it here. No voltage.
So low voltage, and now it's no voltage.
Yeah, we'll do no, because I didn't really give you like, let me see, I have no magnetism, which I already wrote.
So this prior, all those things were for low voltage?
Yes,
Okay.
2 to 6 volts.
Oh, okay.
I know, I should clear that up a little
Yeah,
bit.
no,
Let me see.
I see how.
Sometimes I don't know where I'm going myself.
Hey, Kevin,
Yeah,
could the points being like stuck open cause that too? Because it just constantly forces it to keep going through the resistor instead
sure,
of
that's
staying
bad.
closed?
Bad voltage regulator.
Oh, like
Right?
okay.
Yeah. No voltage at all, no magnetism, or I heard it back there, generator brush failure would cause that. Right? It's not working out of the generator. So those are the most likely causes.
Damaged or dirty commutator. It's catching on something. It's not spinning properly.
Yeah, I'm just gonna leave that as brush failure.
Okay.
I don't know where I'm at here. You can do a regulator bypass.
I doubt that's very good for it though.
Is that a troubleshooting?
Troubleshooting
solution, or-
technique. How would you bypass the regulator?
Temper wire?
Field to ground or field to hot?
That's it. First thing I would do is disconnect and get the voltage regulator out. These are itty bitty tiny little wires that will take absolutely no abuse whatsoever. So I would not screw with those. You want to make sure you don't burn this up, just disconnect. You have your generator just sitting there, start it up. I would have this somehow remote. And so if it's an A-type, what are we going to do?
You're gonna ground the field.
momentary ground the F.
You would, what would you would?
Are you talking like, is it similar to polarizing, or?
Yeah, you just start it up and run it. You go from F, take a jumper wire and hit it to ground. And if you've got a voltmeter, you're going to see it just slam over real quick.
Wait, say that again. You take F.
I did it with you.
I know that, but I want to go over it again because it was something brand new that I did with you. So I want to like.
Okay, so if you have a generator and you're running it, and you have the A and the B post and there's nothing on them, right? You can take the A post and go to a voltmeter. And when you're running it, you should see
Nothing.
Nothing if it's not connected to anything.
about 2 volts,
Oh, or yeah.
2 to 6 volts, because it's running on
Residual
residual magnetism. Then take a jumper wire, clamp it onto the F post, and very briefly take the other end of that jumper wire and go to
Ground.
ground. And the generator output should go to
Max
A lot.
max output, many volts. I would definitely not have this connected to an aircraft at that time. So if the generator's fine, it's going to go max output. So in a B type, yeah, be careful when you're doing stuff like this. B type, momentary jump, F to A plus, or AT as it's going to say. A plus. What's that doing?
Completing
The circuit in the
It's
generator.
completing the circuit instead of going to ground, which we're looking for. Now you're giving it a positive. And what's it going to do? It is going to give you all the volts. Be very careful with that.
Momentary is the key word there.
Yeah, like
I just tap it.
Somebody needs to watch it.
maintenance. Where are you going to find little generators most of the time? Small,
Piston
small piston, older aircraft.
order.
Much older.
Why wouldn't we see it in newer aircraft?
Why would you want a generator?
Because it's
So is
self-exciting.
yours?
You want an alternator?
You're still on generator with yours, or are you?
Oh no, mine came out of the factory with an alternator. You're talking 40s.
Okay.
I'm not trying to have
Oh,
that.
yeah, it's not all different at one time.
No, it's like it's just there's no electricity.
He got the.
Just magnetos.
the-
You can have the electrical circuit you could have.
So in that case, working,
Well, that's the one I put in there, but.
working as an AP, how often
What's
do
the
you
one
see
you put in there?
generators in
Your,
aircraft?
your magnet.
Oh, I saw them all the time because I worked on old airplanes.
Okay.
So it was like just 50-50 for me. All right, maintenance, because that is probably one of the things that was, I know it was, on my DME list was have a student inspect an engine-driven installed generator or alternator. So remember that a lot of generators are belt-driven, but a lot of them are attached to the engine and then driven internally. So, and I keep saying this, when you're asked to inspect something, you know, act like you're really doing it, but don't just go,
I'm done.
I have inspected per your wishes. Speak about it. What are we going to look for? I don't know. You can write
Visual
this.
damage to the.
Visual damage. I could.
Burn marks.
So visual damage sums it up. Inspect flanges for cracks. If it's belt driven, you're going to look at the belt. You're going to look at the brackets that are holding it on. Make sure everything is on and tight and looks good. If it's engine driven especially, how about oil leaking from generator?
Fluids that shouldn't be there.
How often do you change the oil in a generator? Well, it doesn't have oil in it. So what if you have oil leaking out of it? What does that mean?
It's now lubricated. Your bearings broke seal.
You've got a bad seal going from the engine to the, which would be extremely common to have a seal going from the engine into the generator. So if it's leaking oil, you got to pull it off and change the seal.
Are those bearings ever? Are they sealed ever? Are they sealed bearings in there?
No.
No, they're bushings. Huh?
Yeah,
Oh yeah, they're bushings.
yeah.
Even though
So
that's
brush
Now,
wear.
though.
What about corrosion?
I don't see that much. Especially if it's leaking oil, it's not going to corrode.
That's preventative.
Brush wear. How much wear can you have on the brushes?
50% or less.
All right, 50%. We already covered that. Spring tension. All right, honestly, I've never checked spring tension. I mean, you go in there and you kind of make sure that they've got some tension, but more importantly, I would look at the springs and see if they were discolored. They turn blue, or you can tell a bad spring, it'll have nothing on it. So I never got the little tension spring thing out. So
Are they replaced with the brushes?
I never replace brushes either. It's like, because what happens is, if you're maintaining the aircraft properly, when you take the engine apart for overhaul, then that's when you do that. And you overhaul all of that stuff. You put in new brushes, and it'll last you all the way through the overhaul period. So the only reason why you'd be doing this kind of stuff, especially on small airplanes, is if you didn't do it right to begin with. You know, it's like, oh, I have my engine overhauled, put all the old accessories on, which some people do. Commutator, I would always take off this band on the back. I would look in there. I would check make sure that the brushes had plenty of life in them. Look at the springs, make sure they weren't discolored. Look at what the condition of this was on the inside. Is it oily? Obviously, there's going to be dust in there from the brushes and the commutator running against each other, but I will inspect the commutator. Make sure that it is at least reasonably smooth, and I don't see arcing and bad spots on it indicating something. That the mica, and we're going to look at that, which is the insulator material between all these little slats, is not sticking up and causing the brush to kind of run over something. That the mica is down below. Let me see.
Smooth that with
Yeah.
sandpaper.
Yeah, so check for excessive wear. You know, unevenness, a bad looking run, and then check the mica. Yeah, that's the insulator material. What was I going to say? Something you said reminded me of it. What'd you say?
Cleaning them with sandpaper?
Oh, sandpaper. Yeah, so you have to be, I typically don't. If there was oil back there, obviously I would take off the generator, change out the oil seal, and clean out the oil and stuff. You have to be careful what you use on generators. You might have noticed in some of your notes it talked about sandpaper or crocus cloth, but never emery cloth.
Oh, I was gonna ask that. What's 00 sandpaper? That's
Double lot. It's
double-
like
Super fine.
Oh, wait till you get into fixing windshields. There's like 1,000 grit, 8,000 grit. It's literally felt.
Well, so I know, yeah, the highest I've seen was 2,000, but what? Then I didn't put double.
Oh, what's double lot? Is it double lot sandpaper?
That's what
Steel
it said.
wool.
It said 00.
If I think it's steel wool, I would think of double
Well,
lot,
I mean,
triple lot.
yeah.
Steel wool gets, there's like.
Yeah, I use quadruple lot. For like,
But you want to be careful what you use, because like I think your book does say do not use emery cloth, because emery cloth uses aluminum oxide, which sandpaper is silica, but then you get some sandpaper and you look at the back, it just says aluminum oxide sandpaper, which would technically be emery cloth. So if you're embedding metal into what you're doing, then you're going to have problems. So you have to be real careful what you sand this stuff with.
Or brush stone, too. They say brush stone.
Yeah, I've never seen. I'm not brushing it. No. Honestly, if you're getting into doing that, you have to ask yourself, why am I doing this out in the field? Well, you know, if you have a problem, is that the best solution? You know, sometimes the best solution is, hey, let's send this out for an overhaul. You know,
what if
but-
you're the one doing the overhaul?
then you should have all the right equipment, and you would have a lathe that you would be doing this
Yeah.
on. So, what else do I have? Commutator, internal. Oh yeah, and terminals. This is probably the biggest thing. Terminals for tightness. Make sure all the wires are actually connected and not loose.
There's like 6 of them.
And belt tension. I learned something today about belt tension.
Oh,
So
you can't do that. You should teach us how you do it.
I buy the book, and the book says you need 42 inches of deflection. Aircraft manuals are always going to go by deflection with how many pounds. So you'll put X number of pounds on a belt drive belt in the middle, and with X number of pounds, you'll get X number of inches of deflection. But these guys were telling me on cars, you actually can, you roll it.
Yeah, 90
It-
degrees.
roll it.
So I never heard that,
No.
because we don't do that in aviation.
Or doing deflection. both of
But
them.
even though we don't do that in aviation, it's something that would make sense if you're doing an annual inspection. We don't check belt tension on annual inspection by deflection, but you kind of just put your thumb on it and go, okay, that, you know, it's about right. I don't have to worry about it. You kind of tell what's good, what's bad. You would only do that deflection and stuff when you're installing it, but that's a good thing to do. Now I'll do it when I do an inspection annual. So I'll just kind of go, I should roll it 90 degrees.
Do you have
So.
to do you have to measure the distance between the distance, because that would matter too, right?
No, because in the manual it already knows the distance. So
Oh.
like I'm doing on my airplane, it'll
Okay.
say until belt tension until you get 1 to 1.5 inches deflection with 30 pounds. Well, they already know the distance.
Okay.
So it's that nuance. So belt tension. I'll just say belt tension. Belt tension. So I have.
I got the
Oh boy.
Else I don't just-
Overhaul. I have the video, but I think I'm going to let you guys watch that on your own rather than taking up the time. So in Canvas, there's an excellent video. I don't know, it's not airplaney, but it's a guy using a growler. And he shows you how to use a growler. And if you have any help, you just need help, just ask me how do we use the growler. But it's a really, really good video that shows how to measure for opens and shorts in the armature. Normally I show it in the class, but I'm running out of time. So the commutator segments. Can be, it's going to say con. I knew it. I fucking hate you. It's can be, I have trude with an armature lathe. And I actually have an armature lathe that I haven't broke out yet. It's just in the classroom, one of the cabinets, but I'll pull it out. It's a really cool little lathe, about yay big. And you would, to fix the commutator, you put it in this little lathe, and it's got a little belt drive that goes around here, and it just spins the armature, and it's got a cutter that's going to cut right along here and take off material. And you're just going to keep taking off material until this is nice and smooth. Yeah.
Is there a tolerance of how much?
Everything's got a tolerance.
To take off?
Yeah.
Is there another term for truing the commutator?
Yes, there is. It is. I can't think of it. Okay.
Turning the
Turn it.
armature, maybe?
Turning. That's it.
It's like doing a rotor
Yes.
in a car. Just turn.
Turning.
So
Thank
can
you.
put it- you probably would not want to put it in a regular lathe and turn it down that way.
I think you could. I think the reason why it's the same thing.
It's a lathe
And so I would see, honestly, to me, it would be easier to put it in a regular lathe than this stupid thing with the belt that's going to slip. All right, and then the mica is undercut.
How do you undercut the mica after you turn it?
Is an undercut, and I have 0.020. I don't know what that's going to say. 0.02 point. Yes, 0.020. And what that is, and this is, I've done it, and it's painstakingly awful. While it's on that armature lathe, there's this little tiny wheel that I want to say it's like no bigger round than the end of this pin, and it spins at a high speed. And so you lock the armature. The armature doesn't spin; you just hold it in the spot, and you have this little high-speed wheel that's running on a little arm, and you come along and you move it. You have to do every single one, and you have to line it up just perfect. That little wheel. Yeah, remind me. I'll show it to you tomorrow.
Fancy Dremel.
It is on a stick. So Dremel on a stick.
Dremel on a stick.
And so you want that mica 020 below the commutator plates so that the brushes aren't hitting it. And because if the mica doesn't wear at the same rate that the brass of the commutator, then it's going to hop along the mica as it sticks out. So you don't want that. What else do I got here? Oh, we have the growler. And you guys heard that running, right? Yeah. And now you know why it's called a growler. And so that is a machine that has two pads with AC voltage going through it. And so what it does is it induces a voltage into this, because you have AC and AC, which is your field coils going back and forth, inducing a voltage in here. So if you have a voltage in here with 110 volt AC, you're going to get an output here. Not across the whole thing, but where it sits in there. So it'd be like these coils are energized and these, so you have to find the spot over here that's energized. So some will be energized. And what it does is if you have a short between any one of these two, it creates a magnetism out here in these, it's kind of weird, in these laminations, so that a hacksaw blade will vibrate against it. It's very bizarre. So these short out, we'll do that. Tomorrow we'll get it out, we'll play with it in lab and see if we can't get one done.
When it vibrates, do you put it like longitudinally or do you put it laterally?
This way.
Okay, and then it.
Yep. So growler. So what does a growler can do? Checks for shorts in the commutator. It's called a growler because it growls when it's on. Let me see. And then there is the checks for shorts in the commutator. You can also check commutator output. You have to watch the little video. It's not a direct thing, but you take these little probes and you go on adjacent commutators and you'll look, and the meter just gives you a reading. It'll say, well, reading between this and this is a good one. And then there is the light. So there's another set of probes that look like probes off of a voltmeter. And if you touch them together, there's a light that comes on inside of the growler. And there's little holes drilled. You see the light come on. So instead of using an ohm meter to check, do I have continuity or not, and looking at a needle moving, now you just have a light that comes on when you have continuity and no continuity. So you check where you should have continuity and where you shouldn't. Like, you should not have continuity between the commutator and the shaft. That means that this is no longer insulated from this. It's shorted to that. Right? But be careful with the growler, because that little light is running off 110. And those little sticks are 110. So if you touch the little sticks, it kind of gets your attention.
Oh, and it's AC.
It's
so
AC.
It's gonna grip you back.
Yes, it does. Now, I don't think it's exactly 110 coming out of that. I'm not sure. But it's not a pleasant feeling, because I've done it many times until I finally learned to stop doing it.
Somebody's gonna swear.
Yeah, well, he's lived to tell the story.
The case is hot?
Yeah, I barely touched the case with the paint people did the continuity test that guy.
Oh shit.
That's current going through the whole case too.
So light checks for continuity.
You can thus also check for open with that too.
Yes. Well, that's continuity or not continuity, right? So that's the point. Let me say.
I know, just every time I hear it.
Yeah, we'll test the field coils with an ammeter. Test field coils. Test coils. With ohm meter. I mean,
Ohm meter or ammeter?
ohm meter.
Right.
Let's see. Yeah, I'd say check the manual for that. About 20 to 30 ohms. I'm not going to get into every one of these little things. That'll be just too much. Running out of time. Brush seating. Let's see. Brush seating. Yeah, we talked about brush seating. Some manufacturers call for seating the brushes when you put new ones in, because they don't actually hit the way it should. So I want you to run it on a test stand and then like wrap sandpaper around the commutator and run it like that for a little bit, or yeah, abrasive side out.
Or there's a material that it's like a
Yep.
compound.
The compound you can put on there.
How'd you wrap sandpaper around it? Tape it?
Yeah.
Put a little piece of tape
Yeah.
across
Maybe on the inside? Double sided tape.
The way I picture it, just get it longer than it needs to be, and so put it on there, and then make it so it flaps the right way, so that the flap is going to be going this way.
Yeah, and then it always drags against.
Yeah, it'll
Oh,
stay
that's
for a
a-
while. Yeah. Then it'll fling off, get stuck down the generator, and you have to like dig it out. So it'll be a lot of fun.
That's why I was wondering about it. I'm like, wow, that sounds like a mic crank.
Does the manual say to do that?
Like the one you run it.
All right, so I think we're good for generators. I hope.
I'm feeling good.
Good, feeling good about it. We
Ready to start
a little
tomorrow.
deep. All right, so DC alternators. Oh, some books call them AC alternators, or I'm going to call them DC alternators. Being it's an alternator that puts out DC, so an alternator that has a DC direct current output. All right, so they are. Let me see. Hang on. Before I get into that, let's just double check slides. Okay, we covered the equalizing circuit. I actually changed the way I was doing this, so instead of doing a reverse current cutout all on its own, and then doing a current limiter all on its own, and then doing a 2-unit, and then doing a 3-unit, I just jumped to a 3-unit. And I think you guys did okay with that?
Yeah, that's
Okay,
easier.
I think so. This is that growler. So
The guy in the video was like, I restored it. He was all.
he's a cool guy.
Yeah, he was
15
like,
minutes.
So
So do we? You won't say that tomorrow. I still have to do alternators and motors in one day. If we have time, we'll go back to this tomorrow. Okay, alternators. There we go. So we're going to talk about alternators. What kind of engine's that?
An aircraft one?
Lycoming, because it's gray. So that is a belt-driven alternator. That's the way Lycoming does it, right off the front. I kind of like that, because if there's a failure, the belt can just burn and go. What's hilarious is you'll see a lot of people. How do you change that belt?
you change it with the engine off.
Sure, it's real easy to take it off. How you put the new one on?
Cut it again and tape it together.
You got a prop about yay big. I want to see that
You gotta
magic
pull
trick.
a prop. No way.
You got to pull the prop.
Do you put it on like you do a Volkswagen Bug with you run the engine and then you stick it on?
Yes, then put the prop on.
Yeah.
So what is hilarious is I will see so often people put 2 belts on. So they put one belt here that is the running belt, then they'll take the other one and actually put it behind this start. It's called a starter and gear support, and safety tie it up to this right here. So it's just sitting there, just in case they ever need it. Then they just kind of slip that over this, which it will do, and then put it on. But you see, it just sits there on top of an engine that's several hundred degrees.
Yeah, it's cooking the belt out.
And so I bet that this one goes bad before the one running. But, so I was like, well, if that's what you want to do.
Hey, if you want to pay for it, right? Who are we to stop you?
All right. I don't have the Continental version. Continental, like I said, they tend to run theirs off of gear driven. So when it fails, it throws all the pieces into the engine, so you get a new engine too. So, yeah. Although my Continental's belt driven, just in the back.
That's smart.
Yeah. All right. DC alternators. Let's see. So unlike generators, alternators have a rotating field and a stationary armature. Completely backwards from a generator, if you didn't notice. Too many words, too many words. And I don't have a really good picture of an alternator. Too bad. All right, so inside the alternator, these little fingers right here, this is the rotor. And we know it's the rotor because it says rotor, and this spins. I think I actually might have wrote that, I don't know. And the stator stays. So the stator is the stationary thing. Is that the armature of the field? Armature. And the rotor is the moving part, the field. Okay, here's the important point. There's a couple important points. One, and I can tell this is automotive because it has all this in the back. Ours don't. Because it's the field that is rotating And the armature that stays, what is the output, the field or the armature?
The output's the armature.
Since the output is the armature and it's not spinning, we can go direct to outside.
We don't need like a.
So you don't need brushes. No longer need brushes for the output. However, we do have a spinning field, which takes a couple of amps. Not a lot. We have a 30 amp generator. How many amps have to go through the brushes? 30. If I have a 50 amp generator, how many amps go through the brushes?
50.
Okay, so now I have an alternator, and the field takes about 5 amps. So if I have a 110 amp alternator, which would be a common one, how many amps go through the?
About 5.
5. So all we need are little tiny brushes on slip rings, and we never have to convert DC to AC in the field. It's just one side of the slip ring is positive and the other side is negative, and we just put up the 5 amps through those, and there it goes, and energizes the field. So very tiny little brushes, not on a segmented commutator. It runs on a nice smooth ring, so we have absolutely no problems with that. So it's going to last a lot longer. Also, you're going to notice this does not have a reverse current cutout, because what it uses is diodes to transform the AC that's generated in the stator to direct current. And because they use diodes to go from AC to DC out, when reverse current tries to get in, the diode, which is a check valve, will say, I don't think so. So we'll look at that. All right. That's the big takeaway right there. I mean, if you had to tune out right now, that'd be the time to do it. So the stator is the armature. Yes, this eliminates the need for a commutator because commutators have poor brush connection, especially at high power settings. I don't have to write all that. Rotor gets power from slip rings. So the rotor, also called the field, gets power from slip rings. Very smooth, no roughness. So it has 2 of them. One side is positive, one side is negative. Let's see, so we'll say 4 to 5 amps. 4 to 5 amps. So brushes are small.
One side's positive, one side's negative, so one side's input, one side's output. Or
Positive, negative.
Okay.
Yeah. So yeah, you only get about 4 or 5 amps running through.
Output will be in the
Yeah.
this, right?
So they're small, they're going to last longer. And of course there's no arcing in there, which I believe would help cut back on radio noise. The rotor, it also, I should have wrote this sooner, made from 2 pieces, not of, how about from? They have 2 pieces of intermeshing soft iron. That's where we get those fingers. So over here is like piece 1 is going to be all going this way. Piece 2 is going to go that way. And one side is going to be the north fingers, and the other side is going to be the south fingers. So you have north, south, north, south, north, south, the intermesh.
Would
North,
those
south.
also be laminated to prevent eddy currents?
Yes, they would. They are also laminated, probably to prevent eddy currents. Probably. Maybe they're not. Have to take a look.
They're laminated to make them more expensive.
Yes. So alternators. Produce three-phase AC in the stator, which is also the armature. So it's going to get three-phase AC produced in the stator, which we can pick up tomorrow. So they're already checking out.